Chapter 3. More about applications of trigonometry. In this chapter, we goes on to have look one more time about the applications of trigonometry. Last time, we talked about 2 dimension, that means 2D, in the book 4b chapter 10. And this chapter about the applications in 3 dimension, 3D. So before we started, we have a session about review of the application of trigonometry. Let's see. Do you remember how to find the area of a triangle? Besides, you know that in primary school, area of a triangle equals 1/2 times the base and the height. That means if this one is a base, and we need to find the height of a triangle, right? So this one is the easiest one. And you know that last year we have another formula about the area of a triangle. Do you remember? For example, this one. Area of triangle, you can find it by 2 sides and the included angles. That means, okay, here is A, B, C, 3 different sides. If we know that A, B, and the included angle C, then 1/2 times A times B times the side angle C. Then you also can find the area of triangle, right? So any 2 sides and their included angles also can help you. So if you don't know this one, but you know angle A, then 1/2 BC sine A, you also can find it. Same as if you know about the angle B, that means this one, then A and C and the included angle B. So 1/2 AC sine B also can help you find out the area of triangle. Okay? One more formula. Do you remember Heron's formula? If you use a calculator in a formula 3, right? Then very easy. If you substitute A, B, and C, that means the size of the triangle. Okay? Then you can find by this formula. Do you remember? S as the half of perimeter of the triangle. Then S times S minus A times S minus B times S minus C, all together take the square roots. Then you also can find the area of triangle. Okay? Please remember. After about the area of triangle, let's see. Solving triangles. About solving triangles, then we will talk about 2 different formulas or 2 laws. One is the sine formula or sine law. Okay? That means all the sides and the angles have the ratio, and this one equals constant. Okay? It's a constant K. Okay? You can write as, okay, A over side A, B over side B, C over side C, or the reciprocal. Okay? Anyone also can be. But remember, if you write the sine as the numerator, or write in numerator, and the angle side A, side B, and side C in denominator. Sine formula can solve the triangle in these 2 different cases. If you have 1 side and 2 angles are given, then you can solve it. Or 2 sides and a non-included angle are given, then also can solve the triangle. Solve the triangle, that means you can find out all the lengths and all the angles. Okay? The other formula, do you remember? Yeah, cosine formula. A squared equals b squared plus c squared minus 2bc cosine a. And not difficult to memorize. If you keep this one a, then cosine a. For example, okay, I draw a triangle here. Okay, A, B, and C. Here, A, B, side A, side B, and side C. If you have this angle, then we use cosine A. Okay, so A squared equals B squared plus C squared minus 2BC cosine A. That means like this. Okay. If you want to find back the angles, then you can memorize this one. Both can, okay, and make use of your calculator in formula 2. You can solve the unknown, okay? About solving triangles, okay, make use of these two formulas. Okay, how about C? Angles of elevation and depression. This one, if a man stand here, will have a horizontal level. If you look up in the sky, then this angle we say that is the angle of elevation. However, if you have the horizontal level and look down to something, to some position, and this angle we call it angle of depression. That means one goes down and one looks up. Okay? These two kinds of angle will have some question in the practical problem. Okay? About the bearing, do you remember? Yeah, we have two kinds. One is the compressed bearing or reduced bearing. One is the true bearing. Okay, true bearing. About the compressed bearing, remember, we read the angles from north to east or west, or read from south to east or west. Here is east and this one west. Okay? So let's practice in this question. For example, now compass bearing of A from O. Okay, A from O. That means you read it from this direction. Okay, so angle here. So N 30 degrees east. Here is east. N E. And here read the angles. Start from north, so 30 degrees. How about B? Read the angles from south to east, right? So south, east, and inside 52 degrees. Okay? How about C? Remember, you read the angles from south to west. So south, west, and here this time you need to calculate 90 degrees minus 80, so this one 10 degrees. How about D from O? D here, and read it from north to west. That means you need to read the angles from north to west. That means here. So north, west, and this time 70 degrees, correct. Clear? Not so difficult, right? How about true bearing? True bearing, all angles from north. Start from north, then you measure the angles. That means from 0 degrees to 360 degrees. Okay? So, about the true bearing of A from O, so very easy, 30 degrees. However, remember to write the true bearing as 3 digit, so 030 degrees. How about B? That means after 90 degrees, okay, maybe I use another color. That means here, 90 degrees plus this angle, okay? That means the answer is 128 degrees, because this time theta equals 38, right? How about the next one? Yeah, C, that means I read it here from here, okay? Then you can think it as 180 plus 10 degrees, right? So at the end answer, 190 degrees, okay? 190 degrees. How about the last one? Last one, it should be 270 plus 20, right? Because after this one and then add 20 degrees more, so 290 degrees. Okay, so page 1, you have some review about the trigonometry, some about the area, some of it about solving triangles, and about the angles. Please have a review from your textbook on page 1 to 4. There are several questions and you can have some revision. Okay?